In the modern world, every single application will inevitably end up needing to link to other applications. What that means is that every single application will need a way to connect properly and to do it safely. In the Thinkwise Software Platform, we offer a solution for this called Web Connections. Web Connections are a really powerful way to consistently manage API connections. This allows you to maintain all endpoints associated with an API in one place. It supports a range of authentication methods, and they can be managed within your IAM, your Intelligent Application Manager. What this means is that you can change URLs depending on which environment you are using. All in all, Web Connections allow for the use of variables and a lot of reduction in terms of complexity and code. It unifies the way that we manage APIs within the Thinkwise platform. But what does an API look like? An API basically is a service offered by another application to send or retrieve data. To do this, we use what are called API methods. There are various different kinds. The most common ones are get, post, put, and delete. These are different ways of sending data across or retrieving it. So for example, a get is always used to retrieve data, as opposed to a post, which is always used to send data. Now, in order to access the API, we start what is called a base URL. The base URL is basically the link to the application on the internet. Often this will be something like www.baseurl.com/API. To build on top of that, we will then send data to a specific point called an endpoint. The last thing that we will often come across is what are called query strings. Query strings are a way to enrich an endpoint, to add more options to it. One of the most common things would be to add a filter. We will do this today when we are retrieving our customer data. We will be adding a filter to only retrieve active customers. All in all, if we are looking at most URLs for an endpoint, we will be looking at a base URL, then we will add the specific endpoint to it, and then at the end we might include query strings, though query strings are usually optional. Now today we are going to look at two examples of how to do this. We're going to be creating a GET request and a POST request. One of the most common integrations is to retrieve data from other applications. Today we will be getting information about our customers from a CRM application. So here I have the final product, our Thinkwise application, and if I click on customers, we will see that at the moment it is completely empty. So we've got the table already set up, but we have no data. This is because the data is fed by another application. And what we have to do now is retrieve that data from the other application. Now to do that, we will need to know a couple of things. We will need to know the URL we are getting the data from, and we need to know the login details. So if I open up Insomnia, which is an API tool, you can use it to test various different kinds of API and their endpoints. See in the top left that we are executing what is called a GET request. This means that we are retrieving data. We will also see the specific endpoint. So we've got the application WCD, which is the CRM app I was talking about, which has a base URL. So this is always set in stone. This is always the same. This basically just refers to where we can find the WCD application. And then we've got a specific endpoint. In this scenario, we've got the customer endpoint because we want to retrieve data about customers. We are also using a basic authentication. That means we're using a username and password. And on the right, we see the response of the API. What we can now do is take this into the software factory and set it up in a way that we will retrieve the data, this raw data, and then we will process it and store it in that customer table. Now we're in the software factory and we're going to create a new web connection. To do that, we're going to go to the menu on the left and go to Integration and AI and select Web Connections. Every web connection is a model of an API. This will include a base URL and often multiple endpoints. So for our customer API, we can see that I've made a web connection. I've called it Customer API. And we're going to retrieve customer data. This is our base, and often when we are reaching an endpoint, there will be an endpoint after this, but this is where we start. We then have basic credentials as our authentication type with a user and password, it is possible to have different kinds of security. So for example, maybe your API is using a bearer token or an OAuth connection. The next step is to look at the specific endpoints we will be using. So you can see that I've modeled one endpoint. This is the customer endpoint. Our method is a GET request. We are retrieving data, and our path is customer. We are not sending a body along with it. This is something often done when posting. But when retrieving data, often it is not necessary to send a body. What we are also doing is setting a query string. We're adding a filter. As you can see, I'm setting the string filter, and I'm only looking for active values. You might notice here that we've got active between curly brackets. What this means is that it is used as an input parameter. So if we go over to the tab Input Parameters, we will see that there is a parameter called active that has a default value of true. This is really useful because what I can do with this parameter is access it in, for example, process flows. So I can use code to determine what the value of this parameter should be. So if we go back to general, we now see in this third field here, the entire path that will be used for the API call. So we can see the base URL, which is here. We can then see the specific endpoint, which is here. And last, we can see the filter that we've added. So now we've set up the endpoint in terms of input, but we're also getting data back from it. So we also need to set up our output parameters. So if I go to output parameters, you will see that I've created two. Created body, which is the response body, and the response body is everything we get back. And I also want the HTTP status code. This will tell me whether the API request was successfully executed or whether there were any errors or issues. So I can use this to determine the outcome and to determine whether I actually got back a valid response. So now we've set up our endpoint in its entirety. Let's take a look at the process flow that is used to process all of this data. In order to create the process flow, we will go to Processes and open up the process flow screen. There we see that I've got a process flow called Retrieve Customers from API. If I click on Design to look at the flow, you will see that it consists of 3 steps. The first is a Start Table task. This is a dummy task on the customer screen that has only one purpose, to send me a trigger that I want to retrieve the data. Often this would be done using a system flow. If we look in the final application, we will see that we have here a button called Retrieve Customers. This will trigger our process flow. The second step we've got is the web connection. So this is where we actually retrieve the data and where we pass it into a variable. And the last is a decision, process response body. This is where we actually take the response we get from the API and pass it in such a way that it can be used and inserted into our SQL database. So if we look at these steps individually, the first one is nothing special. It's just a table task, retrieve customers, and there is no logic associated with that. It does absolutely nothing else but send a trigger. The second task we have is the web connection. So when we set this up, we select the process action type web connection. We then select the specific web connection we want to be using with the endpoint customer. We also did set up a couple of input parameters, if you remember. So if I look at the input parameter active, we can see that I've assigned a constant value of true to it. If we look at the output parameters, we can see that the web connector itself has a status. This status is not the HTTP status that we just discussed. This is the status of the process flow action itself. If we then look at the endpoint outputs, these are the 2 parameters we defined ourselves. So we've got the body, which is the response body, and we've got the HTTP status code, which is the code sent back by the API that we use to determine whether it was successfully executed. Our last action is the decision node. If I now look at the code that I've assigned to it, we will see on the right here the code that is associated with it. And if we look at the code specifically, there are a couple of things that I'm doing in order to pass this JSON file that we got as a response and turn it into something SQL can actually insert. So at the top, the very first thing I'm doing is checking whether the request was executed successfully. So we've got the HTTP status code, and anything below 300 means that it was successful. And we've got the web connector status. Here, anything that isn't 0, anything that is a negative number, is an error. So if it's 0, it was executed successfully. Any other value than that means that something went wrong with the execution of the web connector. For more specific information about what went wrong, I would suggest you look at the Thinkwise documentation. So assuming that the request was executed successfully and we didn't get any errors, we can parse the data. So we're going to insert into customer. This is our table, customer table, where we want the data to end up. And we're going to parse the JSON data. Now to do that, we have our response body. And we're going to open that. Open JSON is a way that SQL has to read JSON data. I will not fully explain how all of this works, but I will in the description put a link to a blog post made by a colleague of mine that really goes in depth on how to parse JSON in SQL. But basically what we are doing is we are modeling the various columns that we have in the response. Basically, you can treat this almost as if it's a temp table. Once we have our data, we can then treat it as we would any other SQL table. So with the insert into customer, we are basically just describing all the different fields the way we would any other insert statement. So d.name, because the name of our entire JSON is D. It's the alias associated with it. So we have d.name, d.description, address, city, postal code, country, and then the two trace fields that we have. So insert user and insert datetime. I'm filling those specifically with a function to retrieve the user that executes the code and a function called sysDateTime. This will mean that SQL returns the current time as a datetime object. But if we actually look at this in action, we go back to our application, we click the Retrieve Customers button. So this was the dummy button that we just used to trigger the process flow. We click it. We see that it is going to parse for a second, and then we get every single bit of data that we also got in the API. So if we look, we see Madison Reed, description, occasional bio. And if we now look at Insomnia to look at the actual response of the API, we can also see that number 1 is Madison Reed, occasional bio. So what this means is that we've successfully retrieved the data and we've inserted it into our own application. Now that we've successfully retrieved data and stored it in our SQL database, we can say that we've officially created our first web connection, and that is something that we need to celebrate. So we're going to do that by creating another endpoint, a second web connection, just because we love it so much. And just to rub it in, that second web connection is going to be to our team. So we're going to send a Slack message to our team members to make sure that everyone knows that we've just created an epic web connection. In order to send this message to our team, we will need to send a post request to Slack. Now, I've already set this up in Software Factory. So if we go back to the Software Factory and I again go to Web Connections, you will see that we have the customer API that we were working with just a second ago. But we also have Team Slack. Now this is a connection to Slack, and Slack is a little bit different because it uses a webhook. What this means is that I've got a unique access point just for me to send automatically to a specific, group chat in this case. So we've got the base URL, which is hooks.slack.com/services, and then we've got the specific webhook. This is always going to be different depending on the API you're using or the webhook you are using. So if we now go to the endpoint, we will see that we've got the endpoint general because I want to be posting in our general team chat. Last time we were using a get, this time we're using a post. Post means, as the name would suggest, that we're sending data across. We want to send something to the recipient. What is also different is that we are sending a body. When using GET requests, usually you don't have to send a body because you're not really sending something, you're retrieving something. Now we are sending something. So we have to specify what we are sending. So we set the body type to JSON and we get another column on the right. Here, we build our body. So in this case, we only need to send a text across. So I happen to know that for Slack, the only variable is text. and we are again using an input parameter text message, you can always recognize that it is a parameter because it has the curly brackets. So if we start looking at our process flow that will ultimately send the message, we will see that as well. So if I go to send Slack message, which is the process flow that handles the sending of the message, we will see that there are a couple of tasks. So first we have the task send message, and this task is no longer just a dummy task. It also has one output parameter, which is text message. Here we are able to type our message that will be sent. If I go back to the designer, you will see that the next step we are executing is the web connection. So we are again using a web connection. This time it is the Team Slack connection, and we are sending it to the general. If we go to input, we will see the text message input we defined in the web connection, and we are filling it with the text message variable we just filled with the task. Now, in order to know whether it was sent successfully, the last step in our process flow is that if the web connection was executed successfully, indicated by the green line, it will send a message to the user that the message was sent successfully to the Slack channel. If for whatever reason the message could not be sent, it will show the error message, as indicated by the red arrow in the designer. Afterwards, we will always stop the process flow because it is done regardless of whether it succeeded or failed. Now that we've modeled this, let's test it. So I'm going to go back to our application. I'm going to click send message to team, and I'm going to send them a message. I am awesome because I can create web connections. And now they clearly need to know about this as soon as possible. So I'm going to press execute. The message was sent to the team, and because I have notifications set up, I can immediately see that it was indeed sent to Slack. It was sent by another web connection, and it successfully sent our message. So everyone now knows that we are awesome because we can create web connections. I hope that you've enjoyed this quick look at web connections. Please subscribe to this channel for more information and new videos about how to get the most out of your Thinkwise software platform. Also, I would highly recommend taking a look at our Thinkwise community because there are many, many like-minded people who have incredible ideas and who would love to help you if you have any questions. Thank you for watching.